we are told there is a projectile. It's launched from a particular point. And let's assume it's launched at an angle, and we know it would travel in a parabolic path like so. It does split in half, and they both hit the ground at the same time. If it had not exploded, it would land at point X. So this is point X, which is a distance r from to the right of the launch point. But now when it explodes, one of the points lands at point Y, which is a distance 2r. So point Y is over here. So whenever this thing exploded, one piece gained enough velocity to make it to point Y. We're told they have equal mass. So what we have is this particle that has a center of mass given that would travel on the trajectory that would land at point X. Well, if there is an explosion, we know that this left part, the right part, is accelerated and gains an additional horizontal component to its velocity. And the other component gains an impulse, changes its momentum, and its velocity decreases. So the question then is, given this trajectory where it's actually one half of the mass ends up at Y, where will the other half land? Now, if the left half lands at X, then the center of mass will have traveled here to this location, halfway between X and Y. But whether or not there is an explosion, the momentum and the center of mass of this system must follow the same trajectory. So if the one half lands at Y, the other half must land at exactly the launch point. So one half lands here, and the other half must land there. So it's not going to land to the left of the launch point. We think it's at the launch point. Between the launch point and X, somewhere in here, or between X and Y. The only one, since the masses are equal, that will allow the center of mass to still be at the same location is for the center of mass to be at X, is if the other half lands back at the launch point.